Hi, this is our second video in learning how to use Python. So in this video, we will perform an EDA, an exploratory data analysis. We're going to use one dataset. The name of the dataset is Gapminder. It's about the GDP and the life expectancy of different countries. Okay, so let's get started. We're here in Colab. And the first thing that we typically do when we're using Python is we need to import our libraries. When we're using R, we call them packages. In Python, it's more libraries, but again, at the end, is the same thing. So if you want to load one of the libraries that you're going to use, let's say like we need to use pandas, which is one of the most popular libraries when you're doing data science. So you need to import the name of the library. So this will be enough. Import pandas. Now, typically, what you will see in the code in general, most people, is that people assign an alias to the library. So the purpose of that is like, typically is the alias is just like a short way to refer to a library. So when you are typing code, it's easier just to type the alias instead of the complete name of the library. Now, the alias is, it can be any name, but typically the well-known libraries, they have some like well-established alias. So for example, for pandas, most people will use PD. I mean, that's the standard. There won't be a problem if you change the name, it will work, but it's weird. I mean, if something reads your code and you are using a different alias to refer to pandas, that's going to be like, like confusing. All right, so in pandas, this is like the equivalent like to dplyr, tidyverse, I would say, because with pandas you can transform data, we can read data, we can write data into CSV files, Excel files. So yes, it's like part of the tidyverse. Another library that we need here, let me add 3 more. So I'm going to import matplotlib.pyplot as PLT. This one, the second one, it's for visualization. The other one is also for visualization, Seaborn as SNS. And the last one, it's Plotly Express. This one is also for visualization. I mean, with Matplotlib, that's enough. But I want to show you these two, especially the last one, because this one, with the same code, with a simple code, we can create interactive plots. So it's good when you want to create dashboards. So we will see. You will see how to use it later in the video. So remember the alias: pandas PD, matplotlib PLT, Seaborn SNS, and Plotly Express PX. Okay. So here you have a description of the libraries. Now let's get started with the problem. So the first thing that we need is to import the dataset. So I'm gonna upload the file. Remember, you can do this in several ways. So one is just upload it directly from your machine. Another one is to use Google Drive. That's another option. Okay, you get a warning. The warning is just saying like, remember that once you close the session, the file won't be stored here, which is fine. We know that already. Okay, so we have gapminder.csv. So now let's read the file. Actually, it looks similar to our code. So I'm going to create a data frame. That's where I'm going to store the table. In R, we call them tables, right? But here they are data frames. PD, because it's from pandas, the method that I'm going to use right now. The name of the method is read CSV, but please notice that there are like multiple, we have different formats here. You can read CSV, you can read Excel files, you can read HTML, JSON, SAS, SPSS, SQL. There are multiple formats that you can read. So in our case, it's read CSV and then Gapminder. That's the name of the file. Gapminder.csv. Please note that I'm getting an error here. It says, and it's important always to read your errors from the bottom to the top. So here it's name PD is not defined. So it's not recognizing PD. That means that I forgot to run the libraries, because I typed everything here, but I didn't press play here. So now Panda, it's already loaded, so now it should work. Okay, so we get our data frame. So the variables are the country, year, population, continent, life expectancy, and GDP. So this will be like our critical variable, life expectancy. And we have some questions that we want to answer here. So the first question, it's like find the last year available in the dataset and create a dataset using the information of that year. So we can answer that question in different ways. So in one way, it's remember in R we're using a summary to get some descriptive statistics from the different variables in the dataset. But in this case, we call a similar function describe. So describe is gonna provide like some basic statistics. Please notice the notation here. It says data frame dot describe. This is similar to the pipe. Here you can pipe using dots. Maybe simpler, I believe. I mean, I'm okay with either way. Okay, so in this describe, the method provides for each variable the number of observations, the mean value, standard deviation, the minimum value. This is the first quartile Q1, the second quartile or the median, third quartile Q3, and the maximum value. So here you can answer the question right away, because if you check the variable year and we look at the max, it's 2007. So that's the answer to the question. Another possibility to answer the same question. Let me add, I went below this one. Okay, here we can do the name of the data frame, so df, the name of the column of interest, so that will be year, dot, this only will give us the column of the year, right? But we want the maximum value, the most recent year in our data set. We know it's 2007, right? We knew that from the previous step, but again, this is just to show you another way to compute this. You can find that, like, if you want to find the average, it's the mean, max, the maximum value, and in that way you can compute some specific statistic to one specific column. All right. So now we want to create a new data set only with that year. I mean, in the original data set, we have the same country several times. For example, the US. So we have like not just 1 year for the US. We have multiple years. So the new data frame that we're going to create is going to only keep the last observation, like year 2007, for every single country in the data frame. Okay, so let's save the new data frame. I'm going to call it df 2007. I want it to filter our data here. So the way to filter is that I need to add a condition. So let me show you the condition in a different cell, and then I will create the logic to do that. So the condition is the following: data frame and the variable of interest year equal 2007. So here we only get true, false, true, false, false. What is the meaning of that? So what Python is doing is taking this column, the year, right, for every single observation, and it's checking whether the year is equal to 2007. So if it's different than 2007, then you get false. But then in some observations, if it's true, that means that specific row, the year is 2007. So we are going to filter using this condition. So I'm going to take the original data frame, but I want only the rows where this condition is true. Right? So that's our new data frame, only with observations of 2007. So here we have the different countries: Afghanistan, Albania, Angola, Argentina, Vietnam, multiple countries. But again, only the last year, 2007. That was the question. Okay. Now in the third question, it's asking to compute the mean, the median, that's simple, and plot a histogram for this variable and analyze the histogram. So let's visualize. You already know how to compute the mean and the median with this graph, that will be enough. But let's do the histogram. So you need a visualization library. We have three. So I'm going to start with the first one. A matplotlib plt, that's the alias, remember? If I go up, when we loaded our libraries, so we specified, okay, import matplotlib.pyplot as plt. Again, why plt? That's because that's the standard name, but again, you can change it. It's up to you. But my advice is that you should use it, like the standard name, especially for the big libraries like pandas, matplotlib. They are well-established libraries, so everyone will use typically the same alias. All right. So let's create our histogram. So plt hist, and the histogram only requires the x variable, and it will compute the frequencies. So the x variable will be the life expectancy. So from data frame 2007, we'll take the life expectancy. And it will create a histogram. So in the x-axis, we get the years expected, the life expectancy. In the y-axis, that's the frequency, like how many countries are in that bracket or in that bin. So you will see that, like most of the countries, or at least a high number of countries, the life expectancy is between 70 and 80 years, right? So there are a lot of countries in this group, but also there are some countries in this range from 40 to 70. If you're doing an EDA, maybe you will be worried about these countries, right? Because that's a really small value, like life expectancy of 40 years, that's pretty low. Yeah, that's really low. So we will keep an eye on which countries we will find here. All right. So again, if you want to find the mean and the median, because that was part of the question for the 2007. So it's simple, it's just data frame 2007 dot describe and we get the variable for the describe for all variables. But if you want to just focus on the life expectancy, which is fine, you can do the describe only for that column, and we get the mean value, so 67 years, and the median 71.9 years. Remember that these are two different metrics, right? The mean might get affected by extreme values, while the median is not affected by extreme values. The median splits your dataset in two parts. So 50% of observations are above or equal 71.9 years, the life expectancy, and the remaining 50% is below or equal 71.9 years. All right. Now in the question number 4, let's compute the median per continent, mean median per continent. Analyze your results. So we want to compare the performance of the life expectancy per continent, because here in the initial histogram, we have all information, like all together, aggregated, but we are not differentiating between the countries of different continents. So let's do an initial approximation to the solution, and let's plot the life expectancies per continent. So I'm going to use a second visualization library, Seaborn. The alias is SNS, Seaborn. I'm going to use a box plot. In the y variable, I want to see the life expectancy. In the x-axis, I want to see the continent, and the data comes from DF 2007. So with our box plot, our continent, right, and the x-axis continent, y-axis life expectancy. So you can see right away that, for example, Africa, the median value is way below compared to the other continents. In the upper end we have Europe and even Oceania. They are high, but we have few countries here. We will see that later. I think there are only 2 countries. Now we have some observations that are outside the whiskers. For example, here in Asia we have one dot here. This is like life expectancy, like 44 years, more or less. Same thing in our continent here in the Americas. We have one country, it's here. Maybe you might guess which country it's here. Or if you want, we can find them. Now, in this type of plots, it's not just about analyzing the median value. I mean, yeah, of course, that's the first thing, but also, please notice the variation, like how spread are the whiskers. So, for example, in Africa, we have a lot of variability here. In the case of Europe, we have less variability for sure. In Asia, there is a lot of variability too. Okay, so let's try to find, at least for our continent, for the Americas, let's find which country it's the outlier. This is the outlier because the behavior or the way it behaves is different than the observation from the same part of the world. Okay, so let's filter our data just to find which country is that one. So we take the 2007 data frame, DF 2007. We're gonna filter DF 2007. Now the continent equal Americas. So if I leave it like that, it will provide only data set for last year 2007 and only the countries in this part of the world: Argentina, Bolivia, Brazil, Canada, Chile, Colombia, Costa Rica, Cuba, Dominican Republic, Ecuador, El Salvador, Guatemala, Haiti. All right, but now we want to see like the life expectancy. We want to find which is this outlier, right? Because we're doing an EDA, and during the EDA, the idea is to explore our data, understand our data, see like what's weird. So this one, for sure, you need to understand what's happening here. So let's organize our data. Let's sort our data based on the life expectancy from the smallest value to the largest value. So there's a method. Please notice again here. I'm gonna continue the operation. So this is this table is the one that is only for Americas, right? But I want to continue now. I want to take that table dot, and I want to sort values based on the life expectancy. So by life expectancy. So it's doing it from the smallest value to the largest value. So we get that the country with the smallest life expectancy is Haiti, which I guess is not a surprise. 60.9. So of course, compared to other countries, there is a huge gap. Even with the second one, Bolivia, 5 years difference, right there. And now if you compare it with the US, let's find it. This is 2007. But keep that in mind. That was a long time ago. But again, at least this gives you give us an idea. So the US here, United States, is 78.24 according to this data set. So there is a huge gap, 18 years. All right. So now let's answer the question. We haven't answered the question. Remember, let's compute the mean median per continent. Well, we did something similar, but let's use the function group by. So the group by, it works similar that in R. It will put together observations that share the same value for that variable, in this case the continent, and it will compute the metric that you specify. So let's group by So let's take VF 2007. The AI is giving the solution all the time, right? I'm gonna type it anyways. So let's group by continent. And then I wanna take the column life expectancy. And finally, I want to compute the mean value. So it will give us the mean value per continent, right? You can do the same for the median. And you already know, what's the, what you're going to get. So Africa is the continent with the lowest life expectancy. Europe and Oceania, they have the highest values. America is 73.6. So there is a huge difference, Africa compared with the other continents. All right, so let's continue. This is the last question. Remember that during the EDA, you want to analyze the individual variables. That's what we did here. This is the analysis of the individual variable with the histogram, where you check the shape of your data, right? In this case, for the life expectancy. Then we start combining or analyzing two variables at the same time. Here we have life expectancy with a categorical variable, which is the continent, to see if there is if it changes depending on the continent, which and it does for sure. And now let's do one more analysis. In part number 5, we want to check whether there is a relationship between life expectancy and the gross domestic product per capita, the GDP. So for that purpose, remember that these are two numerical variables. So let's use a scatter plot to visualize if there is a relationship or not. So I'm going to use a simple scatter plot initially, and then I will do a better one. So this is using Matplotlib. So scatter. So I'm going to provide the X value is the GDP. So data frame 2007. GDP per cap. And the Y variable, the F 2007, the life expectancy. So in the x-axis you have the GDP, in the y-axis you have the life expectancy. You can see, I mean, it's not a linear relationship for sure, but you can see and I guess it makes sense that as the GDP increases, the life expectancy increases. Again, it's not linear. Now, when you're looking at this plot, you can see some interesting observations. For example, this one, this dot right here. I don't know if you can see my pointer, but in the next plot, you will be able to see what I'm doing. But in this one, there are some countries that even though they have a decent GDP, the life expectancy it's really low, like these countries. Now, on the opposite, on the contrary, we have some countries with small GDP, but they have a high life expectancy. So those are observations of your interest. You want to see which practices, what are they doing, what are the policies that place them there. They're being productive. They are using efficiently their resources. Since I wanna click on the point and see the information, I want something more interactive. So let me show you how to create a better plot. So I'm going to use the third visualization library. Remember, Plotly Express. That library is also available in R. PX, that's the alias. Scatter. Now the parameters are quite the same. So we use the date. We use DF 2007. In the x-axis, we will use the GDP per cap. In the y-axis, the life expectancy. So that creates our plot. I mean, it looks the same, right? You're thinking, oh, it's the same thing. But now the good thing about this one is like, you can explore this. I mean, you can zoom in, zoom out, right? But again, at this point, it's not giving, like relevant information. So let's add more parameters to make it more interesting. For example, we can add color. For the continent. And now we get the observations. So for example, Africa, most of the observations are here, and we knew that, with a small life expectancy. But there are even some countries in Africa that have a small life expectancy, even though they have a decent GDP compared to other countries, but they are not doing good. So that's something you should pay attention. Why? I mean, why are they doing? Why are they here? Even though they have, not a bad GDP compared to other countries, and there are some countries that even with half of the GDP, they have like a higher life expectancy. So there are some questions, some hypotheses that you can create when you're analyzing this. But let's add more information now. You can change the size of the points. So you can define the size of the points based on the population of the country. There's a variable population. Also in our data set. So I guess that's China and India, right? For sure. You can spot them right away. The big dots here. But we want more information. We want to see the name of the country. So we can check the hover name. So once we go over the dot observation, you want to see the country name. That's more useful. Especially when you're doing the EDA, you want to see like more information. So now, for example, this one is China, we knew that, and this one is India. And now we can find which is this country in Africa or South Africa, right? They have a good GDP, compared to other countries, but the life expectancy is small compared to other countries, right? It's interesting, these points here. For example, Vietnam, they have a good life expectancy, almost 75 years, even though the GDP is small. I mean, I'm not an expert here in economy, but these are the type of questions that you might ask when you're performing an EDA. We can make this even more interesting. So let me show you, this will be the last thing that I want to show you, just to show you the potential of using Plotly Express. So I'm gonna animate the plot, but for that purpose, I want this observation to change based on the year. So I mean, this is only 2007, but I want it for all the years in our data frame. So remember, the original data frame is DF, just DF, not DF 2007. So I removed the 2007 to use the original data frame. And the new parameter is animation frame. So it's going to be animated based on the year. Alright, it's running, it's ready. So right now it's not doing anything, but if you click play here, it will start moving. You will see animation, which is nice, right? So you can see the evolution. You can see the evolution of the countries throughout the years. So you can show different pictures, right? With animation, it gives you a different perspective compared to a static plot. So this is how you do your EDA, and you start improving your plots. At the beginning, you will use some basic plots, like the histogram, because initially during the early stages of the EDA, you just want to understand data. You're not creating the plot that you're going to present. Initially, it's just about understanding, getting insights. But once you know what you want to show at the end, so the idea is that you create something for the audience, right? So that's where you start animating your data, using better libraries for the plot. You spend more time in creating your plots. Not at the beginning. It's more at the end when you want to convey a specific message. So that's when you invest time in your plots. Okay, I'm gonna stop the video for now. I hope you enjoyed this EDA session using Python. I'll see you in our next video.